Okay, we're going to be talking about the difference between rational and irrational numbers today. I also included a video for you to listen to of this guy singing a song, which for some people is pretty helpful to understand how to do it. But to start off, our first link is rational numbers. Rational numbers are numbers that can be written as a fraction. So some examples are if something is already a fraction, like 1/2. We could have a whole number, so say I had 2. I can write 2 as 2 over 1, so that's a fraction. We could have, say, 3.5. I can write 0.5 as a fraction, it's 3.5. So 3.5 is called a terminating decimal. I always think of the Terminator when I think of terminating decimals. The Terminator ends people, he kills people. So 3.5 is a terminating decimal because it ends. It ends at 5. There are numbers that go on forever, like pi. This definitely ends. So anytime you have a decimal that ends, it is a rational number. We could have, say, square root of 36, because the square root of 36 is 6, and I can write 6 as 6 over 1. And you could also have repeating decimals. So we put repeating decimals, like if I wanted 0.3 repeating, so 0.33333333 and so on, I'd put a line over it. That line means repeating. So this is 0.3333 and so on. We can also write this as 1/3. So fractions are good. Whole numbers are good, and they can be negative. Rational numbers can be negative. 3.5 is fine because it's a terminating decimal. Square root of 36 is fine because I can turn that into a whole number and then turn that into a fraction. And repeating decimals are fine. Then there are things called irrational numbers. So the prefix ir means not. So this means not rational, which means they are numbers that cannot be written as fractions. This will really only happen twice. The first time is if you have the square root of a number where the answer is not a whole number. So say the square root of, let's go with 6. So the square root of 6, there's no number times itself that gives you 6. I know 2 times 3 is 6, but 2 and 3 aren't the same number. So if you were to put square root of 6 into a calculator, you get this really crazy decimal that goes on forever and does not repeat. So anytime you have the square root of a number and the answer is not a whole number, that's irrational. Pi is the most common example of irrational numbers because they are decimals that go on forever and do not repeat. So that is the second instance that you will see. Decimals that go on forever without repeating. So we're looking at decimals that go on forever without repeating and square roots where the answers aren't whole numbers. So these examples, they just want us to say, are they rational or irrational, and explain. So 4 would be rational. I do want you actually to write it out so you get used to spelling it. So it's rational because 4 can be written as 4 over 1. So that's a fraction. The square root of 9 is going to be rational. And the reason is because I know the square root of 9 is 3. And 3 can be written as 3 over 1. 1/3 is going to be rational. The reason is because it's already a fraction. So remember, rational means can be written as a fraction. So if it's already a fraction, it's definitely rational. The square root of 5, I'm thinking what whole number times itself would give you 5? There is no whole number times itself that will give you 5. So that is irrational. And you could say the reason is because square root is not a whole number. You could also say it's a decimal that goes on forever without repeating. You could also say you cannot write it as a fraction. And then 5 negative 2.5, that's going to be rational because it's a terminating decimal. You could also say negative 2.5, can be written as -2.5. So some people just think, oh, it's negative, that's irrational. No, negatives have absolutely nothing to do with it. If it's -2.5, that's fine. It's still a fraction. You can have negative fractions. So your homework is just identifying if it's rational or irrational. So if you have any questions, feel free to email me.